Students, today we shall see the next point of memory management, that is disk structure. You already know the disk structure. You can see in this diagram that this is the spindle at the center. This spindle passes to the central hole in the cylinders. These are known as the disk. So there are more than one disk in one complete hard disk. This one disk is divided into tracks, which you can see over here, and this track is again divided into small parts, and those are known as sectors. So here you can see this one is a sector. Similarly, there can be more number of tracks in one cylinder or one disk. This disk has an upper platter and a lower platter. This is an ARM assembly which has a read-write head. When we want to read data or write data to the disk, this cylinder goes round and the head moves forward and backward while reading and writing the data. The disk rotates in this way. So this is the disk structure. A magnetic disk is the most commonly used secondary storage medium. So our hard disk is the secondary storage medium. It offers high storage capacity and reliability. So the high storage capacity is of the hard disk, and it is also reliable. Whenever the data stored on the disk needs to be accessed by the CPU, it is first moved to the main memory. So whenever CPU requires any data, it is first copied to the RAM, that is main memory, and then the required operation is performed. Once the operation has been performed, the modified data must be copied back to the disk. So the data which is previously copied to the RAM, if any changes are made to this information, it needs to be saved again to the hard disk. The system is responsible for transferring the data between the disk and the main memory as and when required. Data is represented as magnetized spots on the disk. A magnetized spot represents 1 and the absence of a magnetized spot represents 0. To read the data, the magnetized spots on the disk are converted into electrical impulses, which are then transferred to the processor. Writing data onto the disk is accomplished by converting the electrical impulses received from the processor into magnetized spots on the disk. The disk is designed to reside in a protective case or cartridge to shield it from dust and any other external interference. So the structure which we previously saw in the diagram, that whole structure is put inside a protective case so that the data on it cannot be damaged. Modern disk drives are addressed as large one-dimensional array of logical blocks, where the logical block is the smallest unit of transfer. The size of a logical block is usually 512 bytes. In some disks can be low level formatted to choose a different logical block size, such as 1024 bytes. The one-dimensional array of logical block is mapped onto the sectors of the disk sequentially. Sector 0 is the first sector of the first track on the outermost cylinder. In the diagram I have shown you what are tracks and sectors. The mapping then proceeds in order through the track, then through the rest of the tracks from outermost to innermost. By using this mapping, it should be possible to convert a logical block number into an old style disk address that consists of a cylinder number, a track number within that cylinder, and a sector number within that track. Next point which we are going to see is disk scheduling. Now what is disk scheduling? Disk scheduling schedules the input-output request arriving on the disk. There are several reasons like disk scheduling is important for input-output operations. The first reason for input-output scheduling is in a multi-programming environment, that is where more than one program is running, many processes may send input-output request for the disk. All the processes may try to read the data and write the data to the hard disk. Since the processor can service only one input-output request at a time, others may need to wait on the disk queue. The read-write arm of the hard disk cannot read the data or write the data to the hard disk at the same time of all the processes. It needs to do only one read operation or one write operation of a process at a time. So other processes have to wait. When the current request is finished, another request from the disk queue is scheduled to be serviced. So this is one main reason of disk scheduling, that is multiple processes try to read data or write data to the hard disk, but this is not possible because the hard disk read-write arm can do only one job at a time. So the remaining jobs need to put in a waiting queue. So disk scheduling means deciding which read operation or which write operation of which process is to be done. The second reason is while accessing a particular location on the disk, the current position of the disk arm matters. If the next request is far from the current position, then seek time is more as compared to the other request having less seek time. So the second reason is for the efficient use of the disk arm, we have to do disk scheduling. The third reason is random requests from the users may also need disk scheduling so that various types of requests of different users are serviced. So these are the main three reasons for disk scheduling. Next we are going to see the disk scheduling criteria. That is when we are going to select the request from the processes to read or write data from the disk, which things we are going to consider so that it becomes efficient. So the first thing is seek time. So before this we will see disk input output operation is a major aspect of the computer system. Since it is dependent on the movement of the disk arm, the disk scheduling is performed such that the arm movement is utilized to service more input-output requests efficiently. So to do this, the first criteria which we are going to think about is the seek time. Now what is the seek time? Seek time is the time taken by the disk head to move from one cylinder to another. It is therefore dependent on the seek length, that is the length between the current and the next position of the head. The scheduling algorithm that provides the minimum average seek time is better. So seek time is the time taken, that is the time required for the read-write head to move from one cylinder or the current cylinder position to the next cylinder position. and this should be less while we are doing disk scheduling. So the first most important criteria is seek time. Second is rotational latency. Rotational latency is dealing with how the cylinders rotate. Rotational latency is the time taken by the address sector of the track to rotate into the position that the read-write head is accessible to it. That is, the sector comes under the head. The disk scheduling algorithm that provides minimum rotational latency is better. So previously I have told you all that the cylinder is divided into tracks. So the time required for the read-write head to come to the required track is known as the seek time. Now these tracks are divided into sectors. Now the disk should rotate so that the correct sector comes under the read-write head. That time required is known as the rotational latency. So when we are selecting the request while doing the disk scheduling, we should think of the rotational latency also. It should be minimum. So the second most important criteria for disk scheduling is rotational latency. It is also known as latency time. The third most important disk scheduling criteria is transfer time. Transfer time is the time for data transfer. If it needs to read some data from the disk, then the transfer time is the time taken to transfer the data from the disk to the application. That is, while reading a data, the data transfers from the disk to that particular application. That is the time required to read. It depends on the rotational speed of the disk and the number of bytes to be transferred. So this is the third most important criteria. Next, disk access time. It is the time to perform any operation on the disk. It is the sum of the previously seen criteria, that is sum of seek time, rotational latency and transfer time. So the total access time is equal to seek time plus rotational latency plus transfer time. Next, fifth criteria, disk bandwidth. It is the total number of bytes transferred divided by the total time between the first request of the service and completion of the last transfer of the data. The scheduling algorithm should provide a high bandwidth. So the number of bytes transferred upon the time required from first request to the last request is known as the disk bandwidth. This should always be maximum. Okay. Next criteria, throughput. It is the total number of disk requests serviced per unit time. So how many requests are serviced in a given time is known as a throughput. A scheduling algorithm must provide maximum throughput. So maximum number of disk requests should be serviced in a given time. Next scheduling criteria is the response time. It is the average time spent by a request in waiting. Requests must be serviced within a predictable response time. Otherwise, it have adverse effect on the application. That is, one application is using some data from the hard disk. The read operation is to be performed. If it takes a very lot of time, the application may hang. So always the response time should be minimum. So these are the 7 criteria required for disk scheduling. Whenever a process needs input output to or from the disk, it issues a system call to the operating system. Okay, so whenever we want to read data from the hard disk or write data to a hard disk, it is a privileged instruction. So the operating system will handle this by giving system calls. The request specifies pieces of information. So system calls are same like function call. As we have to pass arguments to a function, we also have to pass arguments to system calls. So in this case, what will be the arguments? The first may be whether this operation is input or output. So the system call which we are giving is for input or it is for output. The second argument may be what the disk address for the transfer is. That is, what will be the cylinder number or track number or sector number from which we have to read information or we have to write information. Next argument is what the memory address of the transfer is. So on a given sector, which is the block number and what is its address. And the last argument, what is the number of bytes to be transferred. So how much data is to be read or how much data is to be written to the disk. So these are the four arguments which will be required for that particular system call. If the desired disk drive and controller are available, the request can be serviced immediately. That is, if the read-write head is idle, it is not doing any reading function or writing function, then the request will be serviced immediately. If the drive or controller is busy, any new request for service will need to be placed on the queue of pending request for that drive. So if the read-write arm is busy requesting doing some other work, then this particular disk request has to wait. So we will put it in a queue. For a multi-programming system with many processes, the disk queue may often have several pending requests. Okay, because there will be more processes running at the same time. Thus, when one request is completed, the operating system has an opportunity to choose which pending request to service next. So from a given queue, the operating system has to select one request. So for selecting that one request from a queue, it may be follow different policies of disk scheduling or disk scheduling algorithms, which we are going to see in our next lectures. Thank you.